All right, in our last video, we were finishing up with this idea that when x cubed was equal to 8, that gave us x was equal to 2. So we said that if we had the point 2, 8 on the original, that would be the point 8, 2 on the inverse. So that means that g of 8 is equal to 2. So let's replace g of 8 with 2. And so now I need the derivative of the original function with 2 plugged in. So let's come back to our original function. The original function was x cubed. So the derivative of that would be 3x squared. And then we're going to put 2 in for x. So let's put 2 in for x. 2 squared is 4 times 3 would give us 12. So we can replace the derivative at 2 with 12. And so our final answer is 1/12. All right, then for number 13, we have the derivative of the inverse of sine of x cubed and arctan or inverse tangent of x. So if we are doing the derivative of inverse sine, that formula is going to be 1 over the square root of 1 minus x squared. And for us, we don't have a plain x here, we have a quantity. So we're going to use chain rule. And so we're going to say 1 over the square root of 1 minus our quantity squared, that's the derivative of the outside, times the derivative of our quantity. And the quantity was x cubed. So the derivative of x cubed is 3x squared. That's the derivative of the inside. All right, over here, I don't have a quantity in terms of inverse tangent of x. I have something raised to the negative 2. All right, so anything raised to the negative 2 is going to be negative 2, that thing to the negative 3. So that's the derivative of the outside, and then I need the derivative of that thing. So the derivative of arctan x would just be its formula, 1 over 1 plus x squared. So if we combine, this 3x squared is going to go in our numerator, and then down here, x cubed squared is x to the 6th. And then here I can put my negative 2 in the numerator, and I can put my arctan to the negative 3. I can move it down to the denominator and have arctan to the positive 3 along with the 1 plus x squared that was down there. And you can write that arctan, or you can write that tan to the negative 1, like inverse tan, either way that you want to write that. All right, then number 14, we have a quantity. We have a product. We have e to the x squared and ln x cubed plus 2. So if we have a product, then we're going to do first times derivative of second plus second times derivative of first. All right, so let's start with first. So first, I have e to the x squared. So if you have the derivative of ln x cubed plus 2, because it's first times derivative of second. All right, so if you have the derivative of ln x cubed plus 2, remember that for ln, we put the original equation in the bottom and its derivative in the top. So the original was x cubed plus 2. And its derivative, the derivative of x cubed is 3x squared, and the derivative of 2 is 0. Okay, so first times derivative of second plus second, now we need the derivative of e to the x squared. So the derivative of e to the anything is just e to that thing. So the outside, the derivative of e to the x squared is e to the x squared. Then the derivative of the inside, we're going to multiply by the derivative of x squared. So that would be 2x. So derivative of outside times derivative of inside. So first times derivative of second plus second times derivative of first. And then we'll just combine anything that we can. So we put these two together in our numerator, and then we just moved the 2x e to the x squared out in front, but that's not necessary. All right, then for 15, we've got the log base 5 of u. All right, so if I've got the log base 5 of u, our property or our rule for that is 1 over u ln a. So this is our a and this is our u, so 1 over u ln a. And then we need to, that's the derivative of the outside. Then we need to do the derivative of the inside. So the derivative of 2x plus 3 is 2. All right, then for this guy, the derivative of 2x cubed, our rule for that is it's going to be 2 to the u ln 2. So 2 to the u ln 2. And then we need to multiply by the derivative of the inside, the derivative of that u, that x cubed. So the derivative of x cubed is 3x squared. And so then you can see we've just done some combinations for those. All right, then for number 16, for this guy, anytime I can simplify first before I take the derivative, it always makes it so much easier. So before I start taking the derivative, I'm going to simplify this. So I'm going to take 5x squared and put it over the square root of x, and 6x and put it over the square root of x. So all I've done is broken that numerator up over its common denominator. Then I'm going to rewrite the square root of x as x to the 1/2 for each of those denominators. Because when your bases are the same and you're dividing, you can subtract your exponents. So x to the second divided by x to the 1/2 would just be 2 minus 1/2, or 3/2. So that would be 5x to the 3/2. And then here, x to the 1 over x to the 1/2, 1 minus 1/2 is just going to be x to the 1/2. So now I can use power rule instead of having to do some horrible quotient rule over here. So for power rule, I'm going to bring my 3/2 out in front. So 3/2 times 5 would be 15/2. And then I'm going to subtract 1 from 3/2, which would be 1/2. So 15/2 x to the 1/2. And then for this guy, I'm going to bring my 1/2 out in front. So 1/2 times 6 is 3x. Subtract 1 from this, so that would be negative 1/2. So 3x to the negative 1/2. Then they wanted me to find that derivative at 1. So let's go through and plug in 1. So 1 to the 1/2 is the square root of 1. And 1 to the negative 1/2 would be the square root of 1 in the denominator. So we'll have 15/2 times 1, which is 15/2, and 3 divided by 1, which is 3. So 15/2 plus 3 would give us 21/2.